In this video, we're going to take a look at section 4.3, which is on factoring out the greatest common factor. Given a list of numbers, the greatest common factor, which is often abbreviated GCF, is the largest number that divides evenly into each of them. You can also think of it this way: it is literally the largest factor that is shared in common. So if you list all the factors for each number, find the biggest one that all of them share in common, and that is your greatest common factor. For the variable factors, I don't know, the wording on this is a little bit convoluted, I feel like. It's kind of the same concept. It's the greatest common factor is the product of the highest power of each variable factor that can divide evenly into each of them. So, and while we're looking for the highest power that can divide evenly into each of them, you want to take the lowest power that occurs, because that is the highest power that will divide evenly into each of your expressions. So really what you want to look for here, and this is how I did it in my face-to-face class. I said, okay, that wording is kind of hard to understand. Here's what you need to do to find the greatest common factor for your variables. Is you take each variable factor that's shared in common. So take each variable factor that's shared in common. So that's a key part of that phrase. It has to be shared in common with all of them. That is shared in common. All right, so I might not have left myself enough room here for all three steps. Step 2, raise each one to the lowest power that occurs. So raise each to the lowest power. And then you multiply it all together. I'm sorry, I'm going to have to write step 3 over here. And then multiply it together. All right, and then that will give you the greatest common factor for your variables. So you really treat the numbers and the variables separately. You find the greatest common factor of the numbers first, then you find the greatest common factor of the variables, and then you put the two together. So take each variable factor that is shared in common, raise each one to the lowest power that occurs, because that is the highest power that divides evenly into each of them, and then multiply it all together. All right, so that satisfies this description. So I think the description is probably technically correct, but just really hard to process. It's not worded very well. So, all right, let's take a look at an example. Hopefully we'll make some sense of it with an example. So let's skip this. We'll come back to it in just a second. So we have this expression here, 12t squared plus 3t. The first thing we need to do is to find the greatest common factor, which I'll abbreviate GCF, of those two terms. Now, terms are things that are being added or subtracted. So there's two terms here, 12t squared and 3t. We want to find the greatest common factor of those two terms. So we have 12t squared, we have 3t. So we'll start by looking at the numbers, right? So don't worry about the variables right now. Let's just look at the numbers, 12 and 3. We want to find the greatest common factor of 12 and 3. So normally the way I come up with the answer is I think of what's the biggest number that divides evenly into 12 and also divides evenly into 3. And it's not a very big number. The answer is 3, right? 3 divides into 12 evenly. 3 divides into itself evenly. And that's the biggest number that will divide into both of these. You could also make a list of the factors if you wanted to. So for example, the factors of 12 would be 1, 2, 3, 4, 6, and 12. All right. These are all the numbers that divide evenly into 12. Those are the factors of 12. The factors of 3 would be 1 and 3. And then you look for the biggest one they share in common. Right? They both share the 3 in common. So the greatest common factor is 3. For the variable part, we take each variable that's shared in common. So they both have this variable t, so they share that in common. And then we raise it to the lowest power that occurs. This t is raised to the second power. This t is raised to the first power. So we are going to take 1 here as the lowest power that occurs. If we went with the highest power, if we thought, well, I want as many t's as possible, I'll choose t squared. Well, t squared divides into t squared just fine, right? They cancel each other out. but t squared is too big to divide into just t. Right? If we tried to take t divided by t squared, it doesn't divide evenly. Right? We'll still have a denominator left here. And so that's too many powers of t to divide into that. So we want to take the lowest power that occurs, because the lowest power is the largest thing that will divide evenly into both of these. So we actually want to keep it as t to the first power. T to the first power divides into t squared just fine. T to the first power divides into itself just fine. So this divides into both of them. And it's the highest power that will do that. So by taking the lowest power that occurs, you're getting the highest power that divides evenly into both of those. So I won't belabor that point anymore after this, but so I'm going to write that as 3t, because to the first power we don't really want to keep that there, because it's just a 1. So that's the greatest common factor. All right, let's try to find the greatest common factor of this one over here. We have the GCF of 20b squared. I don't want to put the minus sign there. I don't know why I did that. And 4b to the fourth power. So we'll start with the number first, the numbers. We're going to find the GCF of 20 and 4. So this one's kind of similar to this one over here. What's the largest number that divides into both 20 and 4? And if you think 2, that is a common factor. 2 does divide into 20. 2 does divide into 4, but it's not the greatest common factor. The biggest number that divides into both 20 and 4 is the number 4. So again, if you made a list of factors, here we have 20. The factors of 20 would be 1, 2, 4, 5, 10, and 20. And the factors of 4 would be 1, 2, and 4. And you want the largest factor they share in common. It's 4, not 2. Oh, the cops just drove by. All right, sorry about that. So 4 would be the greatest common factor of the numbers. All right, and for the variables, they do share a variable factor in common. They both have a b. So we're going to have a b in our greatest common factor, and we'll raise the b to the lowest power that occurs. So we have a 4. Sorry, I got it backwards. We have a 2 and we have a 4. The lowest power is going to be 2. And so that would be my greatest common factor for this problem. Right, now that's only half of what this problem is about. So the first thing you have to do is find the greatest common factor. And then you have to actually factor it out. And so that's the screen I just skipped a moment ago, so let's go back to that. To factor out the greatest common factor, use the distributive property in reverse. So the way I like to describe this, factoring out the greatest common factor, it is undistributing. You are undistributing something from your terms and putting it back outside parentheses. So the distributive property that when we think of the distributive property, everybody thinks of this. We have a times b plus c, and we know that we can take the a, distribute it into the parentheses, multiply it to each of these, so we get a times b plus a times c. And that's why it's called the distributive property, because of that direction. But with any rule that we have in mathematics, if there's an equal sign there like there is here, it works in both directions. So I can flip this around and it works the other way around as well. If I have something like this, if I have AB plus AC, I can rewrite it like this. I can rewrite it as A times B plus C. And what's happening, if you go in this direction, is you're finding a factor that both terms share in common, right? They both have this factor of A in common, and you're going to undistribute it. You take it away from both of them, right? Sorry, I keep pushing. There's a button on this pen that's really hard to avoid pushing, and I keep pushing it, and it's erasing when I do it. So we can take an A away from both of these terms, right? And what's going to be left when we take the A away from both of them is we'll have a B left over from the first term, a C left over from the second term, and then the thing we're taking away gets written one time outside parentheses. And that's how you use the distributive property in reverse. The key is finding a factor that both terms share in common. And that's what the greatest common factor is. It's a common factor that both terms share in common, and it's the largest factor that you can possibly take out, that you can undistribute, right? So that's what we want to do on the problems that we were just looking at, is find that greatest common factor, take it away from both terms, and write it like this. So let's see if we can do that on this first example here. Okay, so I'm not going to do this every time because most people don't bother writing this much detail, but for these two problems anyways, I want you to see the actual greatest common factor getting factored out, being undistributed. So I have 12t squared plus 3t. And what I want to do is rewrite both of these terms so that we can actually see the greatest common factor in each of them. So I'm going to split this up. The greatest common factor is 3t, so I want one of the factors here to be 3t. And what would the other factor have to be so that this would multiply back together as 12t squared? The other factor would have to be 4t, right? 3 times 4 would give me the 12 again, and then t times t gives me the t squared. Right? Plus, we want to do the same thing with this one, except the greatest common factor is already visible. 3t is the greatest common factor, so I'm going to put that one first, but that's everything here. So what do I multiply to that to keep it as just 3t? You multiply it by 1, right? Because 3t times 1 is going to still be 3t. And by doing it this way, we can see the greatest common factor in both of our terms. We have a 3t in the first term, we have a 3t in the second term. So the distributive property kicks in, and it allows us to undistribute, to take away the 3t from both of these terms. And we'll write it one time out front in front of the parentheses. And then in a set of parentheses, we write what's left over. We have a 4t left over from the first term plus a 1 left over from the second term. And that is factoring out the greatest common factor, right, using the distributive property. Right, we can do the same thing with this one. We have 20b squared minus 4b to the 4th power. Let's go ahead and split that one up. We can split it up as we want the greatest common factor as one of the factors here. So we'll have the first one will be 4b squared times, to get to 20 we'd have to have a 5. Right, 4 times 5 gives me 20. And the b squared is already spoken for, right? We already have all of it over here, so that's how that one splits up. Minus, we'll do the same thing here. We want 4b squared. The 4 is already taken care of, but to get the b to the 4th power back, we'd have to multiply by another b squared here. B squared times b squared gives me b to the 4th power. And in this way, we can see the greatest common factor in both of our terms. And now that we see that it's the same in both of them, we can undistribute it. We'll write it one time out in front of a set of parentheses, and inside that set of parentheses we write what's left over, which is 5 minus b squared. All right. Now, most people, most students, most teachers don't bother writing out this middle step. Most people just go from the problem directly to the answer. Once you figure out the greatest common factor, you just go ahead and write it out in front of your parentheses. Let me undo that. I didn't really like how that turned out. All right, maybe use a different color even. So you're going to write it in front of your parentheses. And then you set up your parentheses, and then you just mentally determine what's left over from each term when you take that away. So when I take away the 4, now I know take away sounds like subtraction, but what I mean by that is take away a factor of 4, which means you are dividing it by 4. So when I divide this by 4, I have a 5 left over. I'm taking away 2 powers of b, so no b's are left. And then I do the same thing with this one. I'm taking away the 4, taking away 2 powers of b, so I'll have 2 powers of b left over. And that's how I figure out the answer without having to write it out like this. So you just kind of do this middle step mentally instead of writing it on your paper. And that's what I'm going to do from this point on, and that's how most people do it. So, all right. Now, I have a little bit of an embarrassing mistake on this next page. I noticed this when I was teaching it in my face-to-face class the other day, that this problem somehow got copied again right here. And so obviously I'm not going to do the same problem twice, even though, well, wait, is it the same? No, it's a little bit different, isn't it? See, that tricked me in the last class too. Let's see. No, 20b squared. Yeah, it's the same. 4b to the 4, yeah, it's exactly the same. So skip that one. Let's just do this one here. First, let's find the greatest common factor. And I'm going to, again, do this with the minimal amount of writing. So I'm not going to write the whole setup I had the last time. Let's just write it up here. And we're looking at these two terms. And we want to figure out what's the greatest common factor. So let's start with the numbers. 5 and 20. What's the largest number that divides into 5 and 20? 5. All right, 5 divides into 5. 5 divides into 20. For the variable parts, what variables do they share in common? Well, they both have an x. So I want to have an x in my greatest common factor. And they both have a y. So I want to have a y in my greatest common factor. And then we'll raise each to the lowest power that occurs. So for x, we have 3 and we have 2. The lowest power is 2. For y, we have 2 and we have 3. So again, the lowest power is 2. So the greatest common factor for these two terms is 5x squared y squared. To factor that out, I'm just going to jump to the answer. So I'm going to start by writing the greatest common factor that I just identified first outside some parentheses. Right? So we just write it one time outside parentheses. And then inside the parentheses, we write what's left over when I take that greatest common factor away from both of these terms. So I'm going to take away a 5, 2 powers of x, and 2 powers of y from each of these terms. When I do that with the first term, I take away the 5, so there's no number left. I take away 2 powers of x. We have 3 here, so I'll take away 2. I'll have 1 power of x left over, which I'm just going to write as x, but that's x to the first power. And I'm taking away 2 powers of y, and so there won't be any y's left either. So from the first term, when I take all this away, all I'm going to have left is an x. And then we'll have a minus sign because that's what's in the equation, or in the expression. It's not really an equation. It's what's in the expression. Right, and I'm not really liking how I'm drawing these minus signs here. They're kind of crooked. So there we go. Okay. And then we'll do the same thing here. I'm going to take away a 5 from this 20. I'm taking away a factor of 5. So I'm dividing it by 5, which means I'll have a 4 left from the 20. Taking away both powers of x, so no x's will be left. Taking away 2 powers of y. There's 3 here to begin with, so if I take away 2, there will be 1 left over. And this will be my answer. And you can always double check your answer to make sure that things have matched up correctly by distributing it back in. So if you wanted to check your answer, you could distribute that back into the parentheses, and you would get 5x squared y squared times x. That'll give me 5x to the third power y squared, right? Because that x gets multiplied to those x's, we get 3. Minus 5 times 4 would be 20. We'll have x squared, and then y squared times y would give me y to the third power. And it matches back up to my problem so that I know I have all the right things here. And the other thing you want to double check to make sure you have the right answer is that there's no common factors left inside the parentheses. All right. To be sure you have the right answer. So if there's any more common factors here, for example, if I had a 2 in front of this x, well, now that there's still a common factor of 2 that I could factor out. So I didn't get the greatest common factor like I thought because there's still a common factor left here, and you'd want to go ahead and factor that out and just multiply it to what you've already factored out. So I'd factor the 2 out, and this would become a 10 here. So you want to make sure that what's left in the parentheses has no common factors. All right. So let me take that 2 away. All right. Let's take a look at another example. These are a little bit different because not only do they want us to factor out the greatest common factor, they want us to factor out a negative sign with it. All right, so for greatest common factor, it doesn't really care about positive and negative signs. So that's something that we have to kind of care about extra in addition to finding the greatest common factor in situations where it's relevant. And of course, it's relevant here because the directions say to care about it. So for the greatest common factor, we have 5a and we have 15. We don't care about the sign of those numbers when we're trying to find the greatest common factor. The greatest common factor here, for the numbers, we have 5 and we have 15. The biggest number that divides into both of those is 5. And then for the variable part, they actually don't share a variable in common. So I don't want to put a in my greatest common factor because a is not common to both of them. So to be the greatest common factor, it has to be common to every term that you're dealing with. A is not common to every term, so a does not belong in the greatest common factor. So in fact, in this case, the greatest common factor is just 5. So we're going to factor out the 5, but if that's all we factored out, the answer we get doesn't look quite that nice. I mean, it's not wrong, but it's just, I don't know, it just looks off to me, and I don't know if that's because of how I've been trained to think of it. But if all you do is factor out a 5, what's going to be left in this first term here is you'll have an a left over, and you'll have a negative sign left there, right? You're taking the 5 away, but the negative sign's left, the a is left. Minus, divide a 5 out of this, you'll have a 3 left over. And there's just something about having this first term be negative inside the parentheses that just doesn't look good, to me anyways. And I don't know how, other people might see it, but to me, I just feel like it's not very aesthetically pleasing and just doesn't fit the standard of what I'm expecting to see. So I don't expect to see a negative there. So what we're being asked to do, so this is not the right answer because we didn't follow the directions here. The directions say factor out this greatest common factor, but with a negative sign. So we actually want to factor out -5. So what we're doing here is we're taking away not just the 5, we're taking the negative sign away too. So if I take the negative and the 5 away from this first term, what I will have left is just an A, and it'll be a positive A, which just looks better. All right. And then we're going to take away a negative and a 5 from this. So basically dividing this by -5. So we have -15 divided by -5, which will make that a +3. And so the effect that factoring out a negative sign has is it changes the sign of the terms left over inside the parentheses. This -A ends up becoming a +A. This -3 becomes a +3 because we factored out the negative sign. So all the signs inside the parentheses will switch from what they were originally. And so it's pretty common, if your leading term is negative, to factor out a negative sign with the common factor so that the leading term inside the parentheses will be positive. Just flows better that way, it looks better that way, and it's what most people are expecting to see. So it helps with communicating mathematics so that we set up our work so that it's what people are expecting. Right? So we'll do the same thing here. Greatest common factor is going to be just 2, right? So you look at the numbers, we have 2, we have 8, we have 16. The biggest number that divides into all 3 of those is the number 2. 2 divides into 2, 2 divides into 8, 2 divides into 16. And there's no variable part here because A is not common to all 3. This one is missing an A, so since it's not common to all 3 of them, it cannot be in the greatest common factor. So just a 2 is my greatest common factor, but what I'm going to do, in addition to factoring out a 2, is to factor out a negative sign with it. So we'll factor out a -2. Let's try that again. All right, we'll factor out a -2. We'll set up some parentheses here to hold what's left over. If I take the -2 away from this first term, what I'll have left is a to the 4th power, and it'll be positive. Here, we're taking away a -2, which means we're dividing this by -2. So 8 divided by -2 is going to make that a -4. And then an A will be left there, right? And then the -16 divided by -2 makes this a +8. So again, all of these change sign. This one was negative, now it's positive. This one was positive, now it's negative. This one was negative, now it's positive. So again, that's the effect factoring out a negative has. All right. And so that'll be the result in this case when we factor out a -2. All right, we have one more topic to talk about in section 4.3. It's fairly complicated. It's kind of a complicated topic, but it's fully based on factoring out the greatest common factor. And this topic is called factor by grouping. You only use factor by grouping when there are 4 terms in the thing that you're trying to factor. All right, so the first step is to group the first 2 terms together using parentheses. I don't know if I spelled that right. And group the second 2 terms together using parentheses. So you're going to split your expression up into 2 separate groups by using parentheses. The first 2 terms becomes one group, the second 2 terms becomes another group. Always start with a plus sign between your 2 groups. I always tell students this, and when I see their work, I don't see them following my advice, but it will save you a lot of hassle trying to figure out the right sign of the terms that you're dealing with if you always start with a plus sign between your 2 groups. And if the problem has a minus sign in the middle, you leave that minus sign with that third term inside of its group, and you put a plus sign in place of it. So you always start with a plus sign between the 2 groups, and any minus signs that would have been there stay with the term inside of the second group. And I'll show you what I mean when we get to an example where that happens. Then you factor out the greatest common factor in each of your groups. So you have 2 groups there, factor out the common factor in the first group, factor out the common factor in the second group. What should happen for these problems is the thing that's left over in the parentheses for each group should match up. So the parentheses from the first group should end up matching the parentheses in the second group, which means it's a common factor that you can then factor out again. So step 4 is factor out the common factor again. It will be the part left over in the parentheses in each group. And when you do that, you bring that parentheses out in front, you write it one time in front, you set up a new set of parentheses to hold what's left over, and you'll have these two things being multiplied together, which means you'll have it factored, because factoring means rewrite this so things are being multiplied together. So instead of having 4 things being added or subtracted, you're now writing it as 2 things being multiplied, 2 parentheses that are getting multiplied together. All right, so let's take a look at an example. So we have VQ plus VD plus NQ plus ND. So there's 4 terms here, right? We have 4 things that are being added together. So we're going to try factor by grouping. I'll start by grouping the first 2 terms together. So we'll have VQ plus VD in one group. And then I'll group the second 2 terms together. We'll have NQ plus ND. And that'll be a positive NQ because that's a positive sign, so that'll stay positive. And then in between my 2 groups, I always start with a plus sign. That's the second step. Really isn't so much of a step, it's just I want to emphasize it. And when I would just kind of put a footnote to the process that I always start with a plus sign between the 2 groups, it wasn't getting the attention it needed. So I'm hoping by making it an entire step, it'll catch everybody's attention a little bit better. All right. Now, so the third step was factor out the common factor from each group. So this one, in the first group, there's no numbers. We don't have to worry about that. But for the variables, the only variable they share in common is v, and it's to the first power in both cases. So v is my common factor here. I'll factor it out by writing it one time outside parentheses. And then in parentheses, I write what's left over, which is q plus d. So that's from the first group. For the second group, we'll do the same thing. The common factor here is n, so we factor it out, and then we set up a set of parentheses here. And what's left over from factoring out the n, we'll have a q left over from the first term, plus a d left over from the second term. All right, so that's the third step. The last step is you should have another common factor to factor out, and it should be the parentheses. And that's what we have here. We have q plus d in the first term. We have q plus d in the second term. It's a factor in both of these terms. So q plus d is my common factor now. And so I'm going to factor that out. I don't know why it stopped writing there. So we have q plus d here. We have q plus d here. Just like we were doing with other common factors, this will work the same way. We're going to undistribute it, write it one time out in front, right? Q plus d. Now we're going to keep it in the parentheses that it's already in, but we're writing it one time out front. And then in a new set of parentheses, we write what's left over. So what's left over from this first term is we have a v left over, plus what's left over from the second term is an n. And now we have 2 things being multiplied together, which means it's factored. All right. So that's how factor by grouping works. Let's take a look at another example. All right. So we have s to the third power minus 2s squared plus 3s minus 6. So again, we'll start by grouping. We'll group the first 2 terms together. S to the third power minus 2s squared plus, we'll group the second 2 terms together. So I make sure to start with a plus sign between my 2 groups. That's the second step. The third step is factor out the common factor here. So the common factor would be, there's no number. There's a 2 here, but there's no number here, so there can't be a number as a common factor, but there is a variable that is common to both of these, which is s. And the lowest power of s in this group is 2. And so we'll factor out a 2 with the s. Or not a 2, but a power of 2 with the s. So it'll be s squared that I'm factoring out. That's how I should say it. All right. Take away 2 powers of s from this first term, there'll be 1 power of s left over, minus, take away 2 powers of s from this term, we'll have a 2 left over. All right. Well, the plus sign here, common factor in the second group, there are numbers this time. We have 3 and we have 6. The common factor for 3 and 6 would be 3, right? 3 divides into 3, 3 divides into 6. And for the variables, there's nothing, because while this term has a variable s, this one doesn't. So they don't share a variable in common. So I won't be able to factor a variable out this time, just the number 3. So we take the 3 away from this first term, we'll have an s left over, minus 6 divided by 3 leaves me with a 2 here. And that's what I should expect to see, because these problems should be set up in this way, where once we do the grouping, the parentheses from the first group should match the parentheses from the second group. So we're going to factor that out. We'll factor out the s minus 2. We write it one time out in front, and then we set up a new set of parentheses to hold what's left over when we take that away. When I take away the s minus 2 from this first group, there's an s squared left over. And when I take the s minus 2 away from the second group, there's a plus 3 left over. And then, so that's how that factors. All right. So that is factor by grouping. Now it's going to get a little bit more challenging on this next problem. There's a couple things here. And in fact, I'm really glad that I actually did this lesson already in my face-to-face class, because I made a mistake in my face-to-face class, which I don't want to make when I'm recording a video. And that is the first rule for factoring that you should keep in mind for the rest of this chapter, because we're going to be doing a lot of factoring in this chapter. But the first thing you always do with any problem when you're factoring is look for a greatest common factor. So don't do factor by grouping first. Don't do any other kind of factoring first. Look to see if there is a greatest common factor to all of your terms. And if there is, you factor it out. Right? So I'm looking here, and I didn't catch this in my other class until the end of the problem. And you can fix it at the end of the problem, but it makes it easier usually if you catch it at the beginning. We have a 36, we have a 108, we have a 20, and we have a 60. So is there a common factor? Now, for the variables, there's nothing, because this last term doesn't have a variable. So they don't all four share a variable in common. But for the numbers, they are all even, which means at the very least, 2 should be a common factor to these numbers. But is that the greatest common factor? You should stop and think about that. And what you should determine is that you can actually bring a 4 out. That 4 will be the greatest common factor. So we're going to factor out a 4 to start this problem off. This is not factor by grouping. This is just factor out the greatest common factor. If I take a 4 away from the 36, again, I'm dividing by 4, that's going to leave me with a 9. So we have 9r, I don't know why it's doing that, 9r to the third power, plus, divide this one by 4, we're going to get 27. We get 27r, minus, divide that one by 4, we get 5. So we get 5r squared, minus, divide this one by 4, and we get 15. So that makes the number smaller, which should make it theoretically easier to get through the rest of the problem. All right. So now we're going to jump into the factor by grouping, because we still have 4 terms. So if I want to try to factor this further, grouping would be the technique to use. We're going to group the first 2 terms together. We have 9r to the third power plus 27r. And then we always start with a plus sign between our 2 groups, which means this minus sign here should stay with the 5r squared inside the second group. So I'm going to write that as negative 5r squared minus 15 when I set up my second group. So don't leave that minus sign in the middle. That's a very common mistake students will make. That minus sign stays with the 5 inside the second group with that term. And you always start with a plus sign between your 2 groups. If you do that, you shouldn't have any issues with the signs. All right, now the 4, and I'm a big advocate for copying things down, even if you're not going to use them, even if they're not going to change. But in this case, this 4 can really get in the way of this process, because it doesn't really belong with this process. And if we copy the 4 down here, a lot of students will factor out the common factor here, multiply it to the 4, which it shouldn't get multiplied to, because the 4 is not part of this process at all. So because it's so easy to let it get entangled in what we're doing, we should just leave it out of the picture for now and just bring it back into our answer at the end. So let's not forget about it, but for now, let's leave it out of the picture. So the greatest common factor for the first group, I'm sorry, I'm kind of distracted because there's a big tractor out in front of my house, which is, I live in town, so I don't know why there'd be a big tractor. It looks like they're maybe shoveling snow, but sorry, it's right out of the corner of my eye and it keeps distracting me. The greatest common factor here would be, for the numbers, we have 9 and 27. The largest number that divides into both of those is 9. And for the variables, they do both have a variable in common. And so what's the highest power, or not the highest power, but they both share an r in common. And we'll take the lowest power that occurs, not the highest power, excuse me, I misspoke. We have 3 and we have 1, so the lowest power is going to be 1, right? So we'll take a 9r to the first power out. And if I take that away from this term, the 9 is taken away, 1 power of r is removed, so I'll have 2 powers of r left over, plus we're going to divide the 27 by 9, which is going to leave me with a 3, and I'm taking that 1 power of r away, so there won't be any r's left there. So I'll get r squared plus 3. For the second group, the common factor is 5, right? Because 5 divides into 5, 5 divides into 15, and there's no variable that's shared in common, so there's no variable in my common factor. But if I only factor out a 5, so if I leave it like this, I'll take the 5 away, I'll have a negative r squared left over, and if I divide a 5 out of this, I'll have a minus 3 left over. And the problem with that is that these do not match each other. They have to be exactly the same in order to factor them out in order to complete the problem. So if you can't get these to match up, it's a dead end. All this work is for nothing, because if you get stuck here, you didn't factor. And it's just, I hate to say, it's a waste of time to get to this point and not have it actually work out. So in order for it to work out, these have to match each other. So it doesn't matter. I know it feels like we did a lot of work. It feels like we did a lot of factoring, but we didn't really finish factoring it because we're still adding two things together. We're not multiplying things. And the only way you can get to that last step where you have two things multiplied together is for these to actually match each other. So they don't match, but they're really close, right? They have the same two terms, r squared, 3 and 3, but the signs are off, right? These are both positive, these are both negative. Thankfully, that is something we can fix. So instead of factoring out a 5, what we should factor out is a negative 5. So I'll just erase the whole thing there. All right. So we're going to factor out a negative 5 instead. And that will switch my signs for me so that they will match, right? So factor out a negative 5. If I take a negative 5 away from this, I'll have a positive r squared left over. And if I divide this by negative 5, I'll have a positive 3 left over. Now these match each other, so now I can complete the process, which is factor out the greatest common factor, which is the r squared plus 3, write it one time in front of a set of parentheses, and then inside that set of parentheses, rewrite what's left over, which is 9r minus 5. And then I'm going to go to type this into Math Excel, but we have to remember one thing. There's a 4 here that we left out of the process because we didn't want it to get in the way, but now that we're done with the process, we need to make sure we bring it back into our answer. So this is the answer that you would want to type into Math Excel. All right, we have one more example here. That's another factor by grouping. So this one's a little bit different too. And I guess I didn't mention it today, but at any point when you're watching a video, you can always pause it, try the problem out yourself, and see if you're coming up with the right answer. And you could do that with this one, but there is a little bit of an unusual feature to this problem that we didn't see with the other one, so you might get a little bit stuck, but it wouldn't hurt to try it. So if you want to pause the video, give this problem a try, and then resume it to see if you were on the right track, if you weren't able to get all the way through the problem. This one does not have a common factor for all of us to factor out, or for all of us to factor out. I don't know why I said it like that. This does not have a common factor for us to factor out because there isn't a common factor shared in common to all 4, right? You might say, what about 2? Well, 2 is a common factor to these two terms, but this one doesn't have a 2, this one doesn't have a 2. What about x? Well, this last term doesn't have an x, so there's not anything that is common to all 4 of them that we could factor out. So we're just going to jump right into not greatest common factor. We're going to jump right into factor by grouping because we have 4 terms here. So we're going to try factor by grouping to see if that'll factor it. So I'll group the first 2 terms together. We have x to the 8th power minus 2x to the 7th power. Always start with a plus sign between your 2 groups, and then we'll have x minus 2 in the second group. The common factor in the first group, they both have an x, so we can factor out an x. The lowest power that occurs is 7. So we'll take a x to the 7th power out. When I take 7 powers of x away from this first term, I'll have 1 power of x left. Minus, we'll have the 2 left over here, and we take away all 7 powers of x, so no x will be left in that second term. All right. Plus, now here's what's different about this problem that we didn't see earlier. There is no common factor in this second group. There's nothing to factor out. I can't factor out a 2, I can't factor out an x, because there's nothing common to both of them. So I'm just going to have to copy it down without factoring out a common factor. Let me try that again. I don't like that minus sign. All right. Okay. But it ends up being okay because the essential thing about factor by grouping is that the parentheses from the first group matches the parentheses from the second group. So even without factoring anything out from the second group, we already have a match. And that's the important thing. So we can factor out the x minus 2 from both of these groups. I'm sorry, that's pretty horrible. Write it one time out in front, x minus 2. And then in a set of parentheses, we're going to write what's left over. From the first group, we have left over x to the 7th power. And from the second group, you might say, well, there's nothing left over because we took everything away. But with factoring, there's always something left behind. So even if you take everything away when you're factoring something out, there is an invisible one there that gets left behind. So it's not visible right now, but when you take that away, it has nothing to hide behind, and so it has to become visible. So there's an invisible one here. We take the x minus 2 away, there's going to be a 1 left behind. And so that is what we get as our answer for this one. All right, so that concludes section 4.3 on factoring out the greatest common factor.